Hi, this is Sonia Doucette. In this video, I'll show you how to determine the pH of a salt solution for a salt that yields either an acidic or a basic solution, and where you have to do a little bit of calculating to figure out which one it'll be. For this problem, you're told that N2H5NO2 is added to pure water, and then you're asked if the pH of a solution of this salt will be acidic, basic, or neutral. In water, N2H5NO2 dissociates into N2H5 plus as the cation and NO2 minus as the anion. And the question is, how will these ions interact with water molecules? Before answering this question, it's useful to know which ions do not react appreciably with water. And general rules of thumb for this are that cations that come from strong bases do not react appreciably with water. And these include lithium, sodium, potassium, magnesium, calcium, strontium, and barium. Also, it's useful to know that certain anions that come from strong monoprotic acids also do not react appreciably with water. And these include chloride, bromide, and iodide, and two polyatomic anions, nitrate and ClO4-. So in this case, none of the cations or anions in this list are the cation or anion that we're dealing with. So both the cation and anion that come from the salt we're dealing with when it dissociates in pure water will react in some way with the water molecule to create a more acidic or a basic solution. So N2H5 plus is the conjugate acid of the weak base hydrazine, and it will donate a proton to water according to the following reaction. We have N2H5 plus water giving us a hydronium ion plus hydrazine, N2H4. So the hydronium ion produced from this reaction will make the solution more acidic. However, we also have the nitrate anion, which is the conjugate base of the weak acid nitrous acid, and this conjugate base will accept a proton from water according to this reaction. We have NO2 minus plus water going to nitrous acid when that nitrite anion accepts the proton from water, and hydroxide ion, which is what's left over when water gives up one of its protons. So this hydroxide ion that's added to solution when this salt is added to the solution will make the solution more basic. So based on this information, there's still no clear-cut answer to this question of will the pH of a solution of this salt be acidic, basic, or neutral. In order to determine the answer to that question, you need to compare Ka and Kb values to know for sure. So there are three rules of thumb for doing this. First, if the Ka for the cation, so in this case our cation is N2H5+, is greater than the Kb value for the anion, and in this case our anion is NO2 minus, the solution is acidic because of an excess of hydronium ions. The second rule of thumb is if the Ka for the cation is less than the Kb for the anion, then the solution is basic, and this is due to an excess of hydroxide ions. And the third rule of thumb is that if the Ka for the cation is approximately equal to the Kb for the anion, then the solution will be neutral. And this is because you have approximately as many hydronium ions as you do hydroxide ions. So in order to use these rules of thumb to help us figure out the solution here, we need to find the Ka for N2H5 plus and the Kb for NO2 minus. So the Ka, we need to know the relationship that Ka is equal to Kw over Kb. And specifically, because we're dealing with N2H5 plus, which is the conjugate acid of the weak base hydrazine, then we can use the Kb value for hydrazine in the denominator. We can look that up. So then we have 1.0 times 10 to the negative 14th divided by the Kb for hydrazine, which we find to be 8.9 times 10 to the negative 7. You can find that in a table of base dissociation constants. And then you do the math and you find that the Ka for the cation is 1.1 times 10 to the negative 8th. Now you have to find the Kb for the anion. In this case, our anion is the nitrite ion. So we need to know the relationship Kb is equal to Kw over Ka. So which Ka do we use? Well, we know that NO2 minus, or nitrite, is the conjugate base of the weak acid nitrous acid. So we can look up the Ka value for nitrous acid, and then we can divide that into 1.0 times 10 to the negative 14. And then the Ka value is 4.5 times 10 to the negative 4. If you do the math, you get 2.2 times 10 to the negative 11th. And you can see here that the Ka value is greater than the Kb value, and looking back at the rules of thumb, you see that the criteria we're dealing with here meet that first condition, or that first rule of thumb, and therefore the solution is going to be acidic.